This is part 3 of section 2.3. We have the remainder theorem, and it says if we are dividing a polynomial f of x by x minus a, which is the same kind of case as what we've been doing up here when we are allowed to use synthetic division, then the remainder is given by f of a. In other words, if I had plugged -2 into this equation, and if I did all of the arithmetic, my answer would be -24. Here, if I plugged in 1/3 in for x here and did all of the arithmetic, I will end up with 7/3. Now, just going to show you that this is true because it seems sort of weird. Now, if you look back on the first page of these notes, we had this formula, f of x is equal to d of x times q of x plus r of x. Okay, so this is what we were dividing by. This is the answer, and here is the remainder. Okay, now originally this is r of x because the remainder can be a polynomial. But in this case, since our remainder has to have a degree smaller than what we are dividing by, and this has degree 1, r is going to be a constant. Okay, and this theorem says we are dividing by x minus a. So what we are dividing by is x minus a. Okay, so what I'm going to do is I'm just going to substitute all of this in here. So I have f of x is equal to x minus a times the quotient plus the remainder, and I'm just using r because it's a constant. Okay, now this says if I plug in a for x, I should get just the remainder. So let's do that here. If I find f of a, then I have a minus a times the quotient of a plus the remainder. Well, that's 0. So it doesn't even matter what this is because 0 times anything is 0. And that gives me f of a is equal to r, which is exactly what we're looking for here. Okay, so let's use this. We want to use synthetic division and the remainder theorem to find each function value. Now, I know you're going to be wondering, why do I have to do all the synthetic division and everything when I could simply plug in the number and do the calculation? And I just have to promise you that we will be using these concepts later on. And so we want to be really comfortable with them before we start doing them with variables and things. Okay, so I've got g of x is equal to 2x cubed minus 3x squared plus 1. And I'm going to be doing synthetic division 4 times. If you look here, I have a third power, a second power. I do not have a first power. So right in here, I have plus 0x and then plus 1. Now, synthetic division. I'm going to take the -2, put it in the half box, write down my coefficients here. And then do these calculations. Bring down the 2. 2 times -2 is -4. -3 plus -4 is -7. -7 times -2 is 14. Plus 0 is 14. Times -2 would be -28. And add, that's -27. So since my remainder is -27, this is -27. Do the same thing for negative 1. Bring down the 2. Multiply for negative 2. Add for negative 5. Multiply for positive 5. Add 5. Multiply negative 5 and then add to get negative 4. Negative 4 is our remainder, so this is negative 4. Okay, let's do negative 1/2. Bring down the 2. Multiply for a negative 1. Add negative 4. Multiply is positive 2. Add positive 2. Multiply for negative 1. Add and you get 0. So in this case, our remainder is 0. So this is 0. Now one more. G of 7. Bring down the 2. 2 times 7 is 14. Minus 3 is 11. Times 7 is 77. Plus 0 is 77. 77 times 7 is 539. So this is 540. So this would be 540. Okay, so let's look at a couple more. The factor theorem. A polynomial has x minus a as a factor if and only if f of a is equal to 0. Now think about what we mean by a factor. We mean it divides in evenly, and that means that our remainder is 0. Well, we've said f of a is our remainder, and if our remainder is 0, then it divides evenly, so this was a factor. This is just combining some things that we already know. Okay? Now, what this is saying here, the depressed equation, basically we're going to end up solving large polynomials, and we're going to have to do a division, and then once we have a division that divides in evenly, then we can use our quotient to keep going. So basically we get to simplify the equation and keep going. That simplified equation is called the depressed equation. Okay, one example here. Use the factor theorem to show that the first polynomial is a factor of the second polynomial. Then use synthetic division to find the depressed equation. Okay, so what this is saying is that f of a is 0, and this is supposed to be x minus a. So if I'm using that here, my a value is negative 3. So I could simply plug in negative 3 here and see what I get. Okay, I should get 0 if it is a factor. Let's check it using synthetic division. So I'm going to put a negative 3 here. If it is a factor, I'll have 0 as a remainder, and I'll be able to get the depressed equation out of this. 5, 4, I'm missing the third power. 2, first power constant. So I'm just missing that 1. Okay. Bring down the 1, multiply for negative 3, add for 0, multiply a 0, add a 0, multiply a 0, add is 1. 1 times negative 3 is negative 3, plus 8 is 5. 5 times negative 3 is negative 15, which does give me 0. So it is a factor. Now to get the depressed equation, If you get 0 as a factor, then this quotient is your depressed equation. You just need to put your variables back in. We started off with a 5th power, so this is going to be a 4th power. We always go down 1. So the depressed equation would be 1x to the 4th, no cube term, no square term, plus x, plus 5.